Hello, welcome to Open Source CNC. Here we create toolpaths in FreeCAD and Blender and we turn them into real objects on the CNC. Today I'm going to turn this piece of oak into a personalized paperweight. I decided to make this video to show you how you can adapt the 2.5D engrave operation in FreeCAD 1.1 to make real 3D operations. In this video I will show you how to model this paperweight in the Part Workbench, how to import the SVG logo and adapt it in order to work in the CAM workbench. I will cut the outline using some tags to hold the stock in place. I will show you how to mill the top face using a 3D surface operation, how to set up the engrave operation, and the most important thing, how to make it follow that curved top face. Throughout this video I will be using two macros. If you need them, you can download them together with the file that I'm creating today by following the link in the description, where you can download them for free or together with a small donation. And if you want to support me, you can find the link to my Patreon page in the description of the video, where you have access to all of my videos without any interruptions, without ads, and at the same time you'll help me keep doing these free videos. I'm using FreeCAD 1.1 development version, but it will soon turn into the stable version, so that's why I'm using it. As always, FreeCAD starts in the Part Design Workbench, but as I have told you, we are going to use the Part Workbench today to make this shape. The workflow will be a little different, but we will get the same result. If you are interested in a comparison between the workflow in the Part Design Workbench and the workflow in the Part Workbench, let me know in the comments. I will start by creating the shape of the paperweight. I'm going to use the cube button to create a basic cube, and now let's click on it and modify the dimensions. Set a length of 150 mm, a width of 70 mm, and a height of 40 mm. This matches the shape that I have, a piece of oak of 70 mm wide by 40 mm tall, with an overall length much bigger than 150 mm, but I will use that extra length to hold the piece to the table using screws or clamps. In order to create a curved top surface, I'm going to use a sphere. Select the sphere button, and again let's modify the dimensions. I'm going to set a radius of 450 mm. Now I want to position them so that the roundness of the sphere will be transferred to the top surface of the cube. Because I'm not sure I have the proper dimension set up, maybe I will want to change the radius of the sphere. Let's make this parametric. This means that I will set the top surface of the sphere right in the origin. To do that, go to Placement, Position, and on the Z value press equal to enter a formula, and here I will write minus radius. Click on the OK button, and now I have a Z value of minus 450 mm. After clicking away, the sphere is recomputed and it is positioned correctly with the top of the sphere right in the origin. Let's do the same for this cube. Let's move this top face to be centered in the origin. I could use the draft workbench, set the snapping options, and then move this face to be centered in the origin. But if I change some of the dimensions, any of them, I will have to reposition it each time. In order to avoid that, I will use the same approach as for the sphere, a parametric approach. So let's go to Base, Position. For the X, I will press equal to enter the expression editor, and I will write here minus length divided by 2. The same for the Y. I can either press equal on the keyboard or click on this small icon, and let's write here minus width divided by 2. Press enter. And for the Z, I'm going to lower it so this face is on the origin, which means I need to move it down with the total height of the object. So enter minus height in the Z expression, and now clicking away will move the object exactly where I want. In the Part Workbench, things work a little bit different. I'm building primitives, and then by manipulating them using booleans, I will turn them into what I want. In this situation, I'm going to select the two objects and I'm going to make an intersection. This means that only the areas that are common to both of the objects will be created in this object. You can see that I have the shape of the box, but with the top face on the sphere. One last thing, I will select the vertical corners, holding Ctrl key, and create a fillet with a radius of 3 mm. And now this final object, which is called fillet, Looks exactly as I want. Well, almost exactly, because I don't like the curvature. I think it's too flat. I wanted to have a more pronounced curve, and by doing this I will also show you why it is really useful to create things parametrical. Open the fillet, open the common, go to sphere, and let's scroll down to radius. Change its value to a much lower value, let's say 120 millimeters. Click away and see what happens. You can see that everything updated exactly as I wanted. I don't have to make any other modifications. The object just updated to the new curve of the sphere, which is much tighter. Does this work for any dimension? No. Let's change the sphere radius to, let's say, 80 millimeters. You will see an error this time because the sphere will be smaller. I won't have these vertical edges and the fillet will fail. So, of course, you have some limitations, but if you keep the values in a range that suits your model, using this parametric approach is very useful. Now that we have the shape that we want, let's import the logo. Let's import the SVG logo. I will show you how to import it and how to manipulate it in the Part Workbench so you can use it in the CAM Workbench when creating the toolpath. Go to File, Import, select the SVG file, click on Open, select SVG as geometry, click on Open again, and I recommend you use the 96 dpi. And now I have the object imported, but there are some things that I don't like. For example, this text. I don't think it was imported correctly, but I don't want to engrave the text. I only want the logo, so I can safely delete these 3 text objects. After that, select all the remaining objects, the path objects, and create a compound out of them. This makes them a single object and it will be much easier to manipulate in the CAM Workbench. But I need to position it in the center of this paperweight. In order to do that, again, I will move its center to the origin of the world. Let's go to placement, position. Let's go to the X value and we need to move it to the left. So press equal, start with minus since we are going to move it to the left. Dot shape, which means the shape of the current object. Dot boundbox. Dot X legs. Make sure you respect the uppercase and lowercase, otherwise you will end up with some errors. We still need to divide this by 2 because we want it to be centered. Press OK, click on the Y value or somewhere else, and you will see that it moved exactly to half of the object. Let's make the same for Y, either press equal or click on the little icon to enter the expression editor. And this time I want it to move in the positive area of the Y, so I won't use the minus in the beginning. Dot shape boundbox dot Y length divided by 2. Press OK, click somewhere else, and now I have the object perfectly centered in the world origin. But I still need to scale it a little bit because it's too large for the area that I want to engrave. I'm going to use a little trick, because if I scale this object directly, it will scale it to its initial position, not to the position updated by these 2 values. So in order to keep the current position, let's make a compound out of this compound. Now I can select the new object, the new compound, click on scale and set a factor of 0.65. I think this should do it. And it is scaled, centered in the world origin. I think it's too close to the edges. Again, here's the good part of FreeCAD and of any parametric approach. I can just go to the scale and change its size to 0.60. It will still be centered, but it is slightly smaller than it was before. Now I think it fits correctly and I will be able to engrave it as I want. Now we have everything that we need in the Part Workbench. We have the modeling ready. We have imported the object. We can move to the CAM Workbench, create the job, and then create the operations that we need in order to get our paperweight built to the required shape and to be able to engrave this logo on its top. As always, creating G-Code in FreeCAD starts with setting up the job. First, let's select the objects that we need in order to create the paperweight, the fillet and the scale, holding Ctrl down. Click on the New Job button, make sure you have selected the correct objects, and then click on the OK button. By default, the stock is set as an extended models bounding box with an extension of 1 mm on each of the sides. I don't want that, I want them to be 0. I can either write 0 in all these 6 areas, or in this case, because it's a simple object, I can just select the create box option, which will create a box with exactly the size that I want. The origin is in the center, which I don't want because I will have some problems with adapting the engrave operation in order to get it curved on the surface. So let's move the origin by selecting the corner and clicking on the Set Origin button. You can see now that everything moved. I have the origin in the left corner on the top surface, which is exactly what I want. The next part in setting the job is adding the toolbits. Let's go to the Tools tab, click on the Add button to add the toolbits, and I'm going to use 3 toolbits. A ball end to make the 3D surface, a 6mm end mill to cut the outline, and a VKF toolbit to make the engrave. But as you can see, I don't have a 6mm end mill in the list, and this might be the case for a lot of toolbits when you first start using FreeCAD to generate G-Code. Let me quickly show you how to add the toolbits based on a predefined shape. Click on the Cancel in this window, go to the CAM menu, go to Toolbit Library Editor, and here you have this button which is Add a Toolbit. In the pop-up that opens, select the proper shape, in my case it's an end mill, and now I have a new toolbit here. Double click on it to edit its properties. Let's give it a label, 6mm end mill. Set the cutting edge height of 20mm, a diameter of 6mm, an overall length of 50 and a shank diameter of 6mm. This is my toolbit. Of course, you will use the dimensions corresponding to the toolbit that you are using. Click on OK, and now the new toolbit has been modified. It's now called 6mm end mill. I can close the library manager, go back to the Add button, and I have it here. I can select it. Now I need to set the speeds. I have 3 speeds here, H, V, and spindle. H is a movement in the XY plane, the movement on the X and on the Y axis. I will set it to 3500 mm per minute. V is the speed of movement on the Z axis. I will use a value of 3000, and the spindle is the spindle RPM, which I will set to 19,500 RPM. After adding the first toolbit, I need to remove the default toolbit in order to avoid clutter here in the tools list. Now let's add the second toolbit, which is a 0.79 ball end. And here I have to confess that this is a workaround, because the toolbit that I'm using is a tapered ball end starting from 6mm to a 0.79 radius at the tip. But FreeCAD doesn't have that shape in the predefined list, since the area doesn't have 2 steep vertical walls. This means that tricking it into believing it's just a straight toolbit with a diameter of 0.79 is okay. Remember, if you have steep walls, this trick won't work. You need to create a custom toolbit. For that, you can find the video about creating custom toolbits. But you will see there that there are still some problems with creating and using custom toolbits, so whenever possible I recommend you tricking FreeCAD into using one of the predefined shape toolbits. Let's also give speeds to this toolbit, almost the same as for the 6mm end mill. And the final toolbit that we need to add is the 30 degrees V-bit. Select it from the list. If you don't have it, again go to the CAM menu, to the Toolbit Library Editor, and add it. This time I'm going to use much smaller speeds, 1500 mm per minute, and a spindle of 20,000 RPM, because I want it to move slower so the final result of the engrave will be smoother. Here in the default values tab at the bottom, I'm not sure it's set visible, I need to set the rapid speeds, which depend entirely on the machine. In my case, they are both 6500 mm per minute on the horizontal and on the vertical movements. This won't affect the G-code that you generate, but it helps when calculating the time for the operations. Otherwise, leaving them to 0 will result in a time shown by FreeCAD which will be smaller than the actual time on the machine. One more thing that we need to set is the output. Let's go to the Output tab. We can set a file name, but this is not mandatory. We can set the file name when we click the Post-Process button. But what is important is the processor. It depends on the machine. If you have a Linux CNC machine, you use the Linux CNC post-processor, and so on. In my case, I use a GRBL machine of FreeCAD, which is a fork of the GRBL, so I will leave the processor as GRBL. Let's close the job edit by clicking on the OK button, and I have this job here, which represents the setup of the machine, the toolbits, and everything else that we have changed when creating the job. Usually I make the profiling at the very end of the operations, but this time I'm going to make it first because it will remove the material on this side, which will make things easier for the 3D surface toolbit, the tapered toolbit, which is pretty small at the end. I don't want it to cut the entire height that is going to be here of oak. This means I will set the profile operation first, cut the outline. Of course, I will leave some tabs at the end. And after that I will make the 3D surface and the engraving. Making the profile is as simple as clicking on the profile button, select the tool controller, make sure you have the 6mm 10mm or whatever toolbit you are using for the profiling, click on OK. When clicking on the apply button I will see the default behavior, which needs to be changed a little. And this is because I have two separate objects, which means FreeCAD will mill both of them. As you can see, I also have an outline of this logo, which definitely I don't want. And I don't want it to be cut in the center of the paperweight. To solve that, let's rotate the view, select the bottom face of the paperweight, scroll down to base geometry and click on the add button. Now, clicking apply again, you can see that I only have the outline of the object. There's no outline of the graphics of the logo milled anymore. What still needs to be changed is the step down. The default step down in FreeCAD is equal to the tool diameter, which in my case, I think it's way too large, so I'm going to edit this value, which can only be done by clicking on this icon. If I want to click here and modify it, I cannot write anything. You can see I've rotated the view. So click on the expression editor, and here I can either divide the tool diameter by 3 or I can click on the reset button, and now it turned into a normal value. I can write here 2mm. Click on apply again to see the result. I have many layers now. This is exactly as I want. More passes, but with a lower step down, a lower material removal, so I won't risk breaking the toolbit or moving the stock or any other problems that might occur due to a too larger step down. One more thing that I need to tell you in this video about the profiling operation is the direction. It's not set as conventional or climb, but it's called clockwise and counterclockwise. You have to figure out what type of operation you will end up with based on the direction of rotation of the spindle. I use a clockwise spindle, so using a clockwise moving direction will result in a climb operation. I use the climb operation because even though it doesn't leave a surface as smooth as a conventional operation, it helps a lot to avoid splintering the wood. Oak is pretty prone to splintering, so that's why I'm using a climb cut, which is obtained by using a clockwise direction for the profile operation with a clockwise rotating spindle. Let's close the profile operation and set the final thing before moving on to Universal G-Code Sender to the machine, setting everything and starting to mill this operation. And that thing is adding holding tags, so the piece of material will be held securely in place for the other two operations that we still have to mill after this one. To add the holding tags, open the operations group, select the profile operation, go to this button, click on the little arrow next to it. Make sure you just click the arrow and select the tag dress up. Let me click on cancel, and if you're not using FreeCAD 1.1, if you're still on FreeCAD 1.0, you won't find this button here. How do you get to the dress ups? Go to the CAM menu, and here I have the path dress up sub-menu where I can find the tag. By default it creates 4 tags and only you need 2, and I need them on this side. So let's select the first 2, click on delete. Then select this one, click on edit, move the mouse on any of the layers, it doesn't really matter, but try to keep it centered on this side. Probably here it should do it. Now rotate the view on the other side, select the second tag, click on edit, try to keep it centered, and now click on the apply button to see that the tags have been correctly placed. In order to change the shape of the tags, I will modify some values here. So set a width of 25 millimeters, a height of 10 millimeters, an angle of 80 degrees, and a radius of 3 millimeters. You can play around with these values and see what shape you will end up with. I found out that using these values generally works okay for this type of material, for hardwood. Now that we have the profile operation ready, we have the tag dress up applied. Let's export the job by selecting it in the model tree and click on this button, which is post process. It will open up the G-code Click on the OK button and now save the file, move to Universal G-Code Center and open it there to run it on the machine. Now that we have the outline of the shape, let's make the curved surface. Let's mill the curved surface. After that, we will make the engrave operation and engrave it on that surface. Let me just first select the dress up tag and disable it so we can see better. And let's create a 3D surface operation which we will use for this curved surface. As you can see, it is curved both on the Y and on the X direction. So select the face, click again on this little icon and select the 3D surface operation. If you cannot find the 3D surface operation, here is a short video about how to enable it in FreeCAD. First, let's set the proper tool controller, because by default for any operation created in FreeCAD, the tool controller will be the one used for the previous operation. I don't want to use a 6mm end mill, I want to use the 0.79 ball end. Next, change the cut pattern to zigzag and the step over to 80%. I will click apply and then I will modify one more thing to show you what the difference is. The toolpath looks okay, it will mill the surface pretty good, but I have something really annoying, which is lifting the tool bit and lowering it at both ends. You can see there are a lot of up and down movement, which will increase the overall time a lot. I don't want that, so let's change a few more things. First, I forgot to tell you, if you happen to see some wrong behavior here in the movement of the tool bit, take a look at the sample interval and use a lower value. In this case, I'm going to use a 0.1 millimeters, which represents the resolution, if you want to call it like that. It's the level of detail that you will get in the 3D surface operation. Now, after modifying that, which didn't have anything to do with these up and down movements, let's remove those by checking the Optimize Step Over Transitions checkbox. Let's click on the Apply button again. And all the up and down movements have been removed. I just have one lowering of the tool bit in the start of the operation and then moving it up when the milling is finished. But taking a look at the overall shape, I can see that the tool bit won't pass with the center on this line. This is exactly what I want, otherwise I will end up with some pieces of material here. I want to mill it, I want to mill this surface perfectly from the beginning. Let me show you how to solve that, because it's not that obvious. You cannot find it here. In this dialog, click on the OK button, select the surface and scroll down to the selected geometry settings group. Here I have a boundary enforcement which is checked and I want to leave it like that, but I want to set a boundary adjustment equal to half of the tool bit. In my case, it's going to be 0.4 millimeters. Click somewhere else and the operation will be recomputed and the tool bit will reach the very end of the object. If I zoom in, you can see, of course, there are some approximations in the display, some approximations in the computing of the operation, but overall you get the movement to the edge. I have some additional movements, but I don't think this will be a problem. There are just 4 up and down movements for the entire object. Now let's export the file, let's change the toolbit, let's reset the Z value and run this program on the machine using Universal G-Code Center. We are very close to the peak of this video, the curved engraving. Let's first disable the 3D surface, it's easier to see and it will help us export just the engraving operation. So let's go here, click on the little arrow and select the engrave operation. We need to add the base geometry for the engraving, which means selecting all these lines. This is very annoying, but there are two tools that I'm going to show you today. One is default in FreeCAD, which is this finish selecting loop. If I click on it after selecting one segment, you can see that it automatically selected the entire loop. Scroll down to base geometry, click on add. Repeat the same for the other objects. And now I have all the lines that I want to engrave added to the job. This is very easy for this, which has only 3 objects. But what if there were 20 objects and you had to select them by hand one by one and then use this tool? Let me clear the base geometry and show you an easier method with a macro that I have created. You can find the link to it in the description of the video. You can download it for free or together with a small donation. Go to the tree, open the model group, select the scale model, which is graphics, and run the only edges macro. This will select only the edges of the entire object. So because I had a compound here, all these graphical elements were in just one object. Using this macro selected all the lines in that object. I can now go back to the engrave operation, click on add, and all the edges will be added here. Let's click on the apply button to see the final result. It looks okay. Of course it will be flat. You can easily see from this view, from a front orthographic view, you can see the toolpath, which is flat, but that's not a problem for now. And the depth is set to the diameter of the tool bit, which in this case is minus 0.79. The tool controller is the one used for the previous operation for the 3D surface. So let's change it to the 30 degrees V-bit. Click on the expression, click on reset, and change the final depth to minus 1 millimeter. I think a 1 millimeter engraving should be okay with this tool bit. Click on apply again. You can see it moved slightly lower. Now I can close the engrave operation by clicking on OK. And we need to do one more thing to make it follow this curve. To do that, we are going to use a dress up again. Select the engrave operation, go to dress ups. You can find it in the toolbar or in the CAM menu, and select the ZDepthCorrection dress up. Here I can use a ProPoints file, which I don't have, so I'm going to click on the OK button and leave it just like this. For the next step, again, you will need to use a macro that I have created. You will find the link in the description of the video. You can go there and download the macro for free or together with a small donation. Select the Z-Correct dress up, hold Ctrl and select the face below it, and then run the Add Surface to ZDepthCorrection macro, which will make the toolpath follow exactly this shape. Now all I need to do is export the job again with this operation enabled. Let's go to the machine and see the real reason you've been watching this video all along. Thank you for watching. I hope this video was useful, and remember, if you need one-on-one guidance, you can find the link in the description of the video, be it FreeCAD or Blender. We can meet online and troubleshoot your projects. Also, if you want to support me to keep doing this free series, you can do that by subscribing to my Patreon page. All the help counts, so thank you everybody for supporting me, and see you next time for the next video.